Greeting of the day, dear students. Myself Harish Kumar, and today we are going to learn the fourth chapter of class 10, that is quadratic equation. In chapter number 2, the polynomial, you have seen what is the polynomial and you have seen what is quadratic polynomial. And in chapter number 3, a pair of linear equation in two variable, you have seen what is equation. This chapter number 4 is basically the amalgamation of chapter number 2 and chapter number 3. In this today's video, we will learn about what is quadratic equation, what is the roots of the quadratic equation, how to find the roots of the quadratic equation by using factorization method and by using quadratic formula. We will also introduce you to a new term called discriminant, which is denoted by capital D. We will see how the nature of the roots varies as per the value of the discriminant. We will be seeing three cases: when the discriminant value is positive, when the discriminant value is equals to 0, when the discriminant value is less than 0. So these are the three cases that we are going to see. So let's just start with the today's lecture. So basically, dear students, quadratic equation. So we all know that what is quadratic polynomial. So any equation which is in the form of ax square plus bx plus c, where a, b, c belongs to the real number and a should not be equals to 0 are said to be quadratic polynomial. Okay, so when we equate a quadratic polynomial equals to 0, we get quadratic equation. That means what? If ax square plus bx plus c, which is the standard formula of the quadratic polynomial, when we equate these two equals to 0, we see that this is the quadratic equation. Okay, suppose p of x is ax square plus bx plus c. If we put p of x is equals to 0, then ax square plus bx plus c is equals to 0, and this is called quadratic equation. Okay, this is called quadratic equation, where a is the coefficient of x square, b is the coefficient of x, and c is the constant here. Okay, these they are the real numbers and they may be a rational or the irrational number. Okay, now let us see what is the roots of the quadratic equation. Roots of the quadratic equation. Dear students, we have one small definition. A real number alpha is said to be the roots of the quadratic equation for ax square plus bx plus c is equals to 0. There exists the value of alpha such that a alpha square plus b alpha plus c is equals to 0. Like for every value of alpha which satisfies this given quadratic polynomial is said to be the roots of the quadratic equation. Now dear students, let us take few examples to understand the roots of the quadratic equation. Suppose dear students, I have one quadratic equation which is p of x square plus 3x plus 2 is equals to 0. Here, in order to find the roots of this quadratic equation, we need to find the value of x, that is the real number. It may be any number, like it may be integer, whole number, or anything. So we need to find the value of x such that it satisfies this quadratic equation to the 0. Okay, so one by one let us take by using hit and trial method. So if I take the value of x is equal to 0 in this quadratic equation, I will get 0 square plus 3 into 0 plus 2, which is 0 plus 0, 2. Here 2 is not equals to 0, thus 0 is not a roots of the quadratic equation. Okay, if I put the value of x is equals to 1, this will give us 1 square 3 into 1 plus 2, which is 1 plus 3 plus 2, which is 1 plus 2, 3, 3 plus 3 is 6, and 6 is not equals to 0. This implies that thus 1 is not a roots of a quadratic equation. Okay, now if I consider the value of x is equals to minus 1, we will get minus 1 ka whole square, 3 into minus 1 plus 2. Minus 1 square has a value 1 only. 3 into negative 1 is minus 3, and 2 is just 2. 1 plus 2 is plus ka 3 and minus 3, which is equals to 0. Here the value of x is equals to minus 1, which is the value of alpha, satisfies this quadratic equation to the 0. Therefore, or we can say thus, minus 1 is the roots of the quadratic equation. Now if I put the value of x is equals to plus ka 2, let us see. If I put the value of x is equals to 2, what we will get? We will get 2 square plus 3 into 2 plus 2, which is 2 square is 4, 3 into 2 is 6, and plus ka 2. 4 plus 6, 10, 10 plus 2, 12. So 12 is not equals to 0. Thus 2 is not the roots of the quadratic equation. Okay, now if I put the value of x is equals to minus 2, okay, if I put the value of x is equals to minus 2, what I will get? By putting the value of x is equals to minus 2, I will get minus 2 ka whole square, 3 into minus 2 plus ka 2. So minus 2 ka whole square is plus ka 4, 3 into minus 2 is minus 6 and plus ka 2. Here 4 minus 6 is minus 2 plus 2, which is equals to 0. Here you can see that this x, the value of x is equals to minus 2 satisfies this quadratic equation to the 0. So x is equals to minus 2 is a roots of the quadratic equation. Quadratic equation. Okay, and dear students, keep in your mind that since this is a quadratic equation whose degree rise to 2, so max to max 2 roots are possible. So the value of alpha is our x is equals to minus 1, and another the value of the roots is the value of roots, that is beta is equals to minus 2. So this given quadratic equation is only satisfied for x is equals to minus 1 and the value of x is equals to minus 2. So these are the value of alpha and beta. So since it is a quadratic equation, so max to max 2 roots are possible. Now dear students, let us take another example. Now dear students, in order to understand the roots of the quadratic equation, we are taking another example, which is p of x is equals to x square minus 5x plus 6, which is equals to 0. Dear students, this is a quadratic equation. We aim to find the roots of this quadratic equation by using hit and trial method. So one by one, let us put the value of x, which may be integers, and we will see whether the given integer, the given value of x is satisfies to this quadratic equation or not. So suppose if I put solution, if I put x is equals to 0, it will be 0 square 5 into 0 plus 6, which is just 6, which is not equals to 0. This shows that 0 is not the roots of the quadratic equation. Okay. If I put the value of x is equals to 1, we will get 1 square 5 into 1 plus 6, which is 1 square is just 1 minus 5 minus 4 plus 6 is minus of 2. So this is minus 2, which is not equals to 0. The 1 is not the roots of a quadratic equation. Okay. If I put the value of x is equals to minus 1, what I will get? Minus 1 square 5 minus 1 plus ka 6. Here minus 1 square has a 1, minus 5 into minus 1 is 5 plus 6. So 5 plus 6 11 plus 1 is 12, which is not equals to 0. Thus minus 1 is not roots of the quadratic equation. If I put the value of x is equals to 2, I will get 2 square 5 into 2 plus ka 6. Here 2 square is 4, minus 5 into 2 is 10 plus ka 6. So 4 plus 6, 10 and minus 10. So this will be 4 minus 10 plus 6, which is minus 10 plus 10, which is equals to 0. This shows that 2 is the roots of the quadratic equation. Why? Because for the value of x is equals to 2, we are getting this quadratic equation to the 0. So 2 is the roots of the quadratic equation. Similar to this, dear students, if I put the value of x is equals to 3, I will get 3 square 5 into 3 plus ka 6. 3 square is 9 minus 15 plus ka 6. 9 minus 15. So here basically here 9 plus 16 is 15 and this is minus 15, which is equals to 0. This shows that 3 is the roots of the quadratic equation. So dear students, as you can observe on the whiteboard that for this particular quadratic equation we have got the value of alpha and beta. Since this is quadratic equation, so max to max 2 roots are possible, and most probably the value of alpha is x is equals to 2 and the value of beta is x is equals to 3. Okay, so in this way we can find the roots of the quadratic equation. Okay dear students, now let us see a new term called discriminant. What is a discriminant and how the nature of roots depend upon the discriminant. Dear students, the new term called discriminant is a special relationship between the real number of a quadratic equation. Let us see the small definition of a discriminant. Okay, so discriminant for a quadratic equation ax square plus bx plus c is equals to 0, where a, b, c belongs to the real number and the value of x square where and the coefficient of x square, that is a, should not be equals to 0. This is our quadratic equation. Then a special then a special expression which is b square minus 4ac. Here you can see that this special expression is the relationship between this real number of a quadratic equation. is known to be discriminant, okay, and it is denoted by capital D. So the value of discriminant is b square minus 4ac. Okay, this is the value of the discriminant b square minus 4ac. Okay, now let us see how the nature of roots varies as per the value of the discriminant. Dear students, case 1 that is, if discriminant is greater than 0, that is the value of discriminant is positive, then the nature of the roots will have two real distinct roots. Then it will have two real and distinct roots. For example, if I take p of x is equals to x square minus 5x plus 6 is equals to 0. This is our quadratic equation, where when we compare this given quadratic equation to our standard formula for the quadratic equation, we will get the value of a is equals to 1, the value of b is equals to minus 5, and the value of c is equals to 6, isn't it? And here the value of discriminant will be b square minus 4ac. Putting this value of abc over here, we will get minus 5 square, 4 into value of a is 1 and the value of c is 6, which is minus 5 square is plus ka 25, minus 4 into 6 is 24, which is 25 minus 24 is 1, which is greater than 0. This implies that the value of discriminant is greater than 0. Okay, so it should have two real and distinct root. So let us just verify by using splitting the midterm method for this quadratic equation. So dear students, in order to verify, we have given p of x is equals to x square minus 5x plus 6. Okay, so by using splitting the midterm method, we have to think about two numbers, say p and q, such that their sum is minus 5 and their product is a into c, that is 1 into 6, that is just 6. Okay, so if I take the value of p is equals to minus 2 and value of q is equals to minus 3, I will get minus 2 minus 3 is minus 5. So this is satisfied. And similarly, if I multiply minus 2 with minus 3, I will get plus ka 6. So this is also satisfied. So I can split up this midterm, which is minus 5x, to minus 2x and minus 3x. So let us go for it. So if I erase this and write here, this is equals to 0, and this will give us x square minus 2x minus 3x plus 6, which is equals to 0, which will give us, by taking common x from these first two terms, we will get x as a common, and inside it will remain x minus 2, and here from the last two terms, if we take minus 3 as a common, we will get 3x minus of 2, which is equals to 0. Here again taking x minus 3 as a common, and x minus 2 will be remain. Okay, so here you can see that x minus 3 and x minus 2, these are the linear factor, and we have learned in class 9th that if we equate this linear factor to 0, we get the value of alpha and beta. So equating this linear factor to 0, we will get x minus 3 is equals to 0 and x minus 2 is equals to 0. This will give the value of x is equals to plus ka 3, and this will give the value of x is equals to plus ka 2. And here this is the value of alpha and this is the value of beta. Okay, so since for this particular quadratic equation we have got the value of discriminant greater than 0, which is positive, so as per the rule it should have two real distinct roots. Okay, and we have verified it because here we got two real roots, 3 and 2. Alpha is equals to 3 and beta is equals to 2, which shows that they are two real roots and they are distinct. So this condition is satisfied. So this was the case for the discriminant to be positive. Now dear students, let us take the case 2 when the discriminant value is equals to 0. Okay. Now dear students, let us see case 2. When the discriminant is equals to 0, then we will get two equal real roots. Okay, if the value of discriminant is equals to 0, then we will get two real equal roots. Let us take one example. For example, if I define the quadratic polynomial to be p of x square minus 2x plus 1 equals to 0. This is our quadratic equation. Here, if we compare our quadratic equation with the standard quadratic equation, we will get the value of a is equals to 1, the value of b is equals to minus 2, and the value of c is equals to plus 1. So here a is 1, b is minus 2, and c is 1. Okay, and putting this ABC value to the formula discriminant, which is equals to b square minus 4ac, what we will get? We will get the value of discriminant to be b square, that is minus 2 ka square, 4 into a, 1 into 1, so 4 into 1 into 1, which is minus 2 ka square is plus ka 4, and this is again the 4, and 4 minus 4 is 0, which shows that the value of discriminant is equals to 0. Okay. Now let us verify the things by using splitting the midterm method, which we have already learned in class 9th. So if I equate p of x to the x square minus 2x plus 1 is equals to 0, which is our quadratic equation. So think about two number p and q such that their sum should be equals to minus 2, that is the coefficient of x, and their product, that is p dot q, should be a into c. The value of a is 1 and the value of c is 1, so 1 into 1 is 1. So we have to think about two number p and q such that their sum is minus 2 and their product is 1. So here clearly we can see that if we put the value of p is equals to minus 1 and the value of q is equals to minus 1, we will get minus 1 is minus 2, which is satisfied for this first condition, and minus 1 into minus 1 is just 1, which is also satisfied for the second condition. So the value of, so here we can write minus 2x as a sum of minus x plus minus x. So let us just erase the portion so that we can write So here we can split the midterm of this quadratic equation to p of x is equals to x square minus x plus 1, which is equals to 0. Here by taking common x from the first two terms, we will get x minus 1, and taking minus 1 common from this last two terms, we will get minus 1 as a common, x minus 1, okay, which is equals to 0. Here again taking common as x minus 1, we will get x minus 1 and x minus 1, and this is called the linear factor. Okay, so by the method of splitting the midterm method, if we put the linear factor to 0, we will get x minus 1 is equals to 0 and x minus 1 is equals to 0. Here the value of x give 1 and the value of x here also is 1. This is the value of alpha and this is the value of beta. Okay. Dear students, as you can observe over here that for the discriminant is equals to 0, okay, they should have two equal real roots, and we have got for this particular quadratic equation which we have taken, we have got the value of alpha and beta is equals to 1. Both has a value same, so both alpha and beta are equal. So this is what, when the discriminant is equals to 0, we will get two equal real roots. Okay. Now dear students, let us take the third case when the discriminant value is less than 0, that is negative. Now dear students, let us take the third case. Case third, when the discriminant value is less than 0. Okay, that is when the discriminant is negative. Okay. So whenever the discriminant value is less than 0, it will always have no real roots. If having no real roots, that means it will have imaginary roots. Imaginary roots. Okay. Here dear students, let me tell you, like we have multiple quadratic polynomial whose solution do not exist on a real number. If not exist on a real number, so we have a different term we have kept for it, which is called imaginary. Suppose I take a quadratic polynomial p of x is equals to x square plus 1, which is equals to 0. Okay, and I aim to find the value of x. So this quadratic equation, if we solve it further, we will get x square is equals to minus 1 and the value of x will be under root minus 1. Okay, and to define this under root minus 1, we have one term called I, which is read as iota. So I is equals to under root minus 1. This you should keep in your mind. Okay, this is the imaginary solution for this value of x. For every quadratic equation whose discriminant is negative, we will get no real roots, and that will give us imaginary roots, and imaginary roots are generally denoted by I, which is under root minus 1. Okay, now let us focus on the topic which we were there. Okay, so suppose dear students, I take one polynomial p of x is equals to 2x square minus 4x plus 3 equals to 0. This is my quadratic equation. Okay, and when we compare our quadratic equation to the standard formula of quadratic equation, we get the value of a is equals to 2, the value of b is equals to minus 4, and the value of c is equals to 3. Okay, and here the value of discriminant, which is b square minus 4ac, by putting the value of a, b, c over on this formula, we will get b square, that is minus 4 ka square minus 4 into a is 2 and the value of c is 3. So this is 3. This will give us minus 4 square is a plus cos 16, 4 into 2 is 8, 8 into 3 is 24. So it's a minus 24, which will give minus 8, which is less than 0. This implies that for this discriminant, which for this quadratic equation we have discriminant d, which is less than 0. Okay, now so one more formula we have to learn, dear students, which is called quadratic formula. What is quadratic formula, sir? A quadratic formula is generally used for the quadratic equation whose discriminant is less than 0, that is negative, and the quadratic formula is x is equals to minus b plus minus under root of discriminant upon 2a. Okay, this is the formula that we are going to use to find the imaginary root of this quadratic equation. So here for x is equals to minus b, the value of b is, we are having minus 4, so it will be minus 4 plus minus discriminant. The value of d we have got is minus 8, so this will be minus 8 upon 2 into a. The value of a is 2. So this will be minus plus ka 4 plus minus under root minus 8 divided by 4. Okay. And here one more thing, dear students, the prime factor of 8 is 2 into 2 into 2. Okay, you can find by using this formula 2, 4, 2, 2, 2, 1. So the prime factor of 8 is 2 into 2 into 2, and which we can write as 2 square into 2. So here x is equals to 4 plus minus 4. Here I can write 2 minus of 2 into 2 ka square divide by 4. Okay. 4 divided by 4 is 1 plus minus this root 2 ka square, inside this under root will come out, so it will be 2, and remaining will be minus root 2 divided by 4. 2 and 2 will cancel out to each other by 2 times, and this will remain as plus 1 plus minus root 2 divided by 2. Okay, and here as you can see that we can write minus root 2 as a product of minus 1 into root 2. Okay, and we know that this root minus 1 is iota, which is root minus 1 is iota into root 2. So this will be root 2 iota. So root minus 2 can be rewritten as root 2 iota. So I can write this as a 1 plus minus root 2 iota divided by 2. So here the value of x, which is equals to alpha, is 1 plus root 2 iota divided by 2, and the value of x, which is the value of beta, is x minus 1 minus the value of x, which is equals to beta, is 1 minus root 2 iota divided by 2. Okay, so for this quadratic equation 2x square minus 4x plus 3, we have got the value of alpha is equals to 1 plus root 2 iota divided by 2, and the value of beta is equals to 1 minus root 2 iota divided by 2. So these are the two roots of the two imaginary roots. Here it will call imaginary roots. Okay, because iota is attached to this, and which is sum of this. So this is called imaginary roots of this quadratic equation. Okay, dear students. Now we will see the method of factorization to find the solution of any quadratic equation. Okay, so let's just go for it. Now dear students, we are going to solve a quadratic equation by using the method of factorization. Under this method of factorization, dear students, what we generally do is that we express the given quadratic equation as the product of their linear factor, either by using splitting the midterm method or by using some algebraic identities. And once we express the given quadratic equation as the product of their linear factor, we equate those linear factor to 0 to get the value of alpha and beta. Suppose dear students, we are having the general formula for the quadratic equation is ax square plus bx plus c, which is equals to 0. Okay, and we are saying that alpha and beta be the two roots of the quadratic equation. So we express this alpha and beta as a product of their linear factor. Suppose x minus alpha and x minus beta is equals to 0. Here this is the linear factor. So from this quadratic equation, either by using splitting the midterm method or by using some algebraic identity, we will convert this quadratic equation as the product of the linear factor. Okay, as the product of the linear factor, and by putting this linear factor individually to the 0, that is x minus alpha to 0 and x minus beta to 0, we get the value of x is equals to alpha and the value of x is equals to beta. Okay dear students, now let us take one example so that you understand it better. Suppose dear students, I have taken one example. Suppose we have one quadratic equation which is p of x square root 3 plus 1 x plus root 3 is equals to 0. Okay, we aim to find the solution for this quadratic equation by using the method of factorization. Okay, so what we will do, so let us just expand this quadratic equation. So we will get p of x is equals to x square root 3 x minus 1 x, so minus 1 x plus root 3 equals to 0, isn't it? Now taking common from first two term, taking x as a common from this first two term, we will get x minus root 3, and by taking minus 1 as a common from this last two term, we will get minus 1 x minus root 3 is equals to 0. Okay, this implies that again by taking x minus root 3 as a common, we will have x minus root 3, that will be equal, and x minus 1 which is equals to 0. This is called, dear students, linear factor. Okay, now equating this linear factor to 0, that is x minus root 3 is equals to 0 and x minus 1 is equals to 0, we get the value here we get the value of x is equals to root 3, and here the value of x is equals to 1, and this is the value of alpha and this is the value of beta. So dear students, this is called the method of factorization. Let us take one more example so that you understand it better. Okay, suppose dear students, we are given one question which is find the value of x for 4x square plus 4bx minus a square minus b square whole bracket is equals to c. We have to find the value of x by using the method of factorization. Okay, so as you can see dear students, it is very much hard to express this given quadratic equation as the product of linear factor by using splitting the midterm method. Okay, so we will solve this question by using some algebraic identities. So let us just open this expression and try to solve the things. So solution starts here. So given p of x is 4x square plus 4bx minus a square minus b square equals to 0. Okay, if we open this bracket, we will get 4x square plus 4bx minus a square minus plus, so plus ka b square which is equals to 0, isn't it? Yes. Now if we rearrange this given algebraic expression and shift this b square to here and this a square to that side, we will get 4x square plus 4bx plus b square minus a square is equals to 0, isn't it? Yes. Now here I can write this 4x square as a 2x ka whole square, and I can express this as a twice of 2x into b plus b square minus a square is equals to 0. Okay, so basically what I have tried over here is that I am just trying to put this expression as in the formula of a plus b whole square, which is a square plus b square plus 2ab. Okay, so from this expression I will get 2x plus b ka whole square minus a square is equals to 0. Yes or no? Yes. We can write this here. This expression can be rewritten as this by using this algebraic identity, which is, now dear students, we can expand this algebraic expression by using this identity, which is a square minus b square is a minus b whole bracket a plus b whole bracket. Okay, so we can write this expression using this identity as a 2x plus b minus a whole bracket 2x plus b plus ka a whole bracket is equals to 0. Okay, this is called बच्चों linear factor. Okay, so far we have expressed this quadratic equation as the product of linear factor by using two algebraic identities, and I have written algebraic identities on the bracket. So we have expressed this quadratic equation as the product of the linear factor by using these two algebraic identities. Now the next step is to equate the linear factor to 0. So by equating this linear factor to 0, we will get 2x plus b minus a is equals to 0, and here 2x plus b plus a is equals to 0. Here the value of x will be, let me shift this to this expression on the RHS. I will get 2x is equals to positive ka a minus b. Here the value of x will be equals to a minus b divided by 2 by shifting this to the RHS. So multiply will change to divide, and the value of x will be a minus b divided by 2. On the other hand, we are having, when we shift this on the RHS, we will get 2x is equals to minus of a minus of b. Okay, so taking minus as a common one, we will get a plus b. Okay, this will give the value of x is equals to minus a plus b whole divided by 2. So the value of alpha is a minus b divided by 2, and the value of beta is minus of a plus b divided by 2. So this is the method to solve the quadratic equation by using the method of factorization. Okay, now let us see one more example so that you understand it better. Dear students, there are some questions which ask you to find the value of x by using the method of factorization, which requires both method as a helping method, like the question that I have given on the whiteboard, which you can see right now. Dear students, this question requires both method of splitting as well as algebraic identity to express this quadratic equation to get the value of x. So I request you all to either pause the video and try solving this question by your own, otherwise just see how I am solving. Okay, dear students, for this question a is equals to x minus a plus b x minus a is equals to 2. Question is this. So by using cross multiplication method, we all know that this will multiply with this will multiply with this, and their denominator get as a product on the resultant denominator. So this can be written as a x minus a plus b x minus b whole divided by x minus b and x minus a, which is equals to 2. Yes or no? Yes. Now numerator part can be expressed as a into x, ax, a minus a, that is minus of a square, b into x is plus ka bx, b minus b is minus b square whole divided by x into a whole divided by x into x is x square, x into minus of a is ax, minus b into x is minus bx, minus b into minus a, minus minus will be positive, and a b into a is just ab. This will be equals to 2. Okay. Now shifting this to the RHS, we will get ax is equals to a square plus bx minus b square, which is equals to twice of x square minus ax minus bx plus ka ab. This will give 2x square, 2ax, 2bx, 2ab. Okay. Now here this we can write this as it is, so it will be ax a square plus bx minus b square. Okay. Now let us shift this all expression which is written on LHS to the RHS, and we will get 2x square minus 2ax minus 2bx plus 2ab minus of ax plus of a square minus of bx plus of b square, which is equals to 0. Okay, dear students, since we have shifted to that side, and we can rewrite as a writing this on the first, and since we have shifted to that side, so all the sign will be changed. So as you can see, I have changed all of this sign to like that and equated the things to the equals to 0. Okay, so now let us try to identify and cut some expression. Since I can see that minus 2ax and minus ax are like terms, so generally like terms are added, so we will add this expression and rewrite as 2x square minus 2x minus ax, that is minus ka 3ax. Okay, minus 2bx and minus bx, so this will be plus ka, this will be minus ka 3bx, this will be minus ka 3bx. Okay, and also a square plus b square plus 2ab we have written as it is, which is equals to 0. Here you can observe, dear student, that this is nothing but our algebraic identity, which is a plus b whole square. So I can rewrite it as a plus b ka whole square, which is equal to 0. And from here, if I just try to take common, like as a 2x square, here I can take 3 and x as a common, so this will be a plus ka b whole bracket x plus b. Okay, so here, dear students, as you can see that this given expression is nothing but in the form of our standard quadratic equation, which is ax square plus bx plus c. Okay, so when we compare this, which is, let us say it is equation number 1. Okay, so dear students, if we compare equation number 1 to our standard formula, we will get the value of a is equals to 2, the value of b is equals to minus 3a plus b, and the value of c is equals to a plus b whole square, isn't it? Okay, now here we are going to use splitting the midterm method. So we need to think about two number p and q such that their sum p plus q is b. The value of b is minus 3a plus b, and their product should be, that is p dot q should be c dot a, that is the value of a is 2 and the value of c is a plus b whole square. So the product of p and q should be twice of a plus b whole square. Okay, so here we have to think about the value of p and q such that their sum is minus 3a plus b whole bracket and their product is 2a plus b whole square. Okay, so here dear students, if I take the value of p is equals to minus 2a plus b and the value of q is equals to minus a plus b. Okay, this is minus a plus b. I will get that minus 2a plus b minus a plus b is minus 2 minus 1, that is minus 3a plus b, and at the same time if we do the product, that is minus 2a plus b into minus of a plus b, this is what, nothing but 2 into 1, since both are negative so it will be positive, so it will be just 2 into 1 is just 2, a plus b, that is a plus b whole square. Okay, so for the value of p is equals to minus 2a plus b and the q is equals to minus a plus b, we are having their sum is equals to minus 3ab, which is satisfied, and their product is twice of a plus b whole square, which is also satisfied. So here for this equation number 1, I can rewrite the midterm, that is minus 3a plus bx, as a sum of the minus 2a plus bx plus minus a plus bx. So let us make some space so that I can write. So continuing here to there, then somewhere here. Okay, I am making space. Okay dear students, so I can write this 2x square minus 3a plus b whole bracket x plus a plus b whole square is equals to 0 as by using splitting the midterm method as a 2x square 2a plus b x minus 1, that is minus a plus b x plus a plus b का whole square, which is equals to 0. Okay, from here dear students, from this first two term you can take 2x as a common, and what will remain inside the bracket will be x a plus b open bracket, one more time open bracket, and from this two term we will take minus a plus b as a common, and what will remain inside it will be x minus a plus b open bracket ka whole bracket, which is equals to 0. Okay, this will be equals to 0. Now again taking common, which is x minus a plus b, x minus a plus b. From here we will get 2x a plus b open bracket and x minus a plus b open bracket, which is equals to 0. This is called bachcho linear factor. Okay, now we will equate individual linear factor to 0 to get the value of x. So from here I can get the value of x is equals to 2x minus a plus b is equals to 0, and this will be x minus a plus b, which is equals to 0. This will give the value of 2x is equals to a plus b, which implies that the value of x is a plus b whole divided by 2, and from here the value of x will be a plus b. So this is the value of alpha and this is the value of beta. Okay, so for this quadratic equation we have got the value of x as a two roots, which is first root is x is equals to a plus b divided by 2, and another one is x is equals to a plus b, which is the value of, this is the value of alpha and this is the value of beta. I hope you all have understood the things. Let us take more example. One question might be visible to you in your screen. Let me read the question for you. Find the value of p for which one root of the quadratic equation px square minus 14x plus 8 is equals to 0 is 6 times the other. Okay, you have to find the value of p for which one root is 6 times the other for this quadratic equation, which is px square minus 14x plus 8. Everyone try by your own, pause the video and try it by your own. Yes, everyone try it by your own. Now see the solution. Dear students, we are given the quadratic equation px square minus 14x plus 8 is equals to 0. It is said that one root is 6 times the other. So if we assume that alpha and beta be the two roots of the quadratic equation. So according to question, it is given that alpha is 6 times the beta. Okay, it is written on the question that one root is 6 times the other. So if alpha is the one root, so the alpha will be 6 times of the other root, which is beta. Okay, dear students, when we compare this quadratic equation to our standard formula, we get the value of a is equals to p, the value of b is equals to minus 14, and the value of c is equals to 8. Isn't it? Yes. And from the quadratic polynomial and this quadratic equation, we also know that the sum of the roots of the quadratic equation is minus b by a, and the product of the two roots of the quadratic equation is c upon a. So putting the value of a, b and c on the RHS, we get alpha plus beta is equals to minus b. The value of b is minus 14, so it is minus 14 divided by A is P. So this is just 14 upon P, isn't it? Okay. On the other hand side, alpha dot beta, the value of C is 8 and the value of A is P. Okay. So alpha dot beta is 8 upon P. Now taking alpha plus beta is equals to 14 upon P as a equation number 1, and taking alpha dot beta which is equals to 8 upon P as a equation number 2. Okay. Now dear students, if I put the value of alpha which is 6 beta in equation number 1, I will get 6 beta plus beta is equals to 14 upon P, which is 7 beta is equals to 14 upon P, isn't it? Okay. This give the value of beta is equals to 14 upon P divided by 1 upon 7. So this will be cut 2 times. So the value of beta is 2 upon P. Yes or no? Yes. So the value of beta is 2 upon P. So keeping it as a equation number 3. Now dear students, we will substitute the value of equation 3 in equation number 1. So on putting 3 in a 1, we will get the value of alpha B, just alpha. The value of beta is 2P, which is equals to 14 upon P. This implies that the value of alpha will be 14P minus 2 divided by P, which is, since here the denominator is same, so it will be just 14 minus 2, which is 12 divided by P. 12 divided by P. So the value of alpha is 12 divided by P, which is, let us take it as a equation number 4th. So equation number 3rd give the value of beta, and equation number 4th give us the value of alpha. Okay. But our aim is to find the value of P. So what we will do, dear students, we will put the value of equation 3 and equation number 4 in a equation number 2nd. So putting equation 3 and equation number 4 in a 2nd, what we will get? We will get the value of alpha as 12P into the value of beta is 2P divided by P, which is equals to 8 divided by P. Okay. So here we can see that this will be equals to what? This will be equals to, I am just writing over here, 12 into 2 is 24 divided by P square, which is equals to 8 upon P. Here 1P will get cancelled out, and we know that 8 is 3 times of, when 24 is 3 times of 8, so it will be cut for the 3 times. So what will remain here? It will be 3 divided by P, which is equals to 1. So the value of P will be equals to just 3. Okay. When you transpose the value of P to here, you will get the value of P is equals to 3. So dear students, this is the solution of this question. So for the value of P which is equal to 3, this given quadratic equation is satisfied. Okay. So this is the board question. Now let us do some another question. Dear students, one question might be visible to you in your screen, which says that if the sum of the roots of the quadratic equation ky square minus 11y plus k minus 23 is equals to 0 is 13 upon 21 more than the product of its roots, then find the value of k. Okay, so first everyone try by your own. You can pause the video and try to solve this question. Okay, so now I am solving on the blackboard. Dear students, the quadratic equation is ky square minus 11y plus k minus 23 is equals to 0. Here, when we compare this given quadratic equation with our standard formula, that is ax square plus bx plus c is equals to 0, we will get the value of a is equals to k, the value of b is equals to minus 11, and the value of c is equals to k minus 23. Okay, so here according to question, alpha plus beta is 13 upon 21 more than their product. Okay, in question it is given that the sum of the roots is 13 upon 21 more than the product of the roots. So this is what, and we know that alpha plus beta is what? Alpha plus beta, we can write it as a minus b by a. So alpha plus beta is minus b by a, and this is what 13 upon 21, and we know that alpha dot beta is it's c upon a. What is value of b here? The value of b is minus 11. So this is what, when you put the value of a, b, c in this expression, we will get the value of b is minus 11 divided by k, 13 upon 21 plus k minus 23 divided by k. This will give 11 upon k is equals to 13 upon 21, which is equals to here k divided by k will be 1 and minus of 23 divided by k. Okay, so here by variable separation will transpose this to the LHS. We will get 11 upon k plus 23 divided by k is equals to 13 upon 21 plus 1. This is what, here since the denominator is same, so we will add the numerator as it is. So this will be 434 divided by k. Okay, and here it will be 13 by taking LCM, which will be 1 into 21 divided by 21, which is 34 divided by k, 13 plus 21 divided by 21. This is what, 4 divided by 21. This will be 34. Okay, this will be 34 divided by 21. So this will give 34 divided by k is equals to 34 divided by 21, and 34 will get cancelled out. This will be 21 is equals to k. So the value of k is equals to 21. Okay, so the answer, the value for the k is 21. So in this method we can solve this question. Okay. Dear students, before we proceed to the next question, I just wanted to tell you something very important, which is two-digit number. Suppose, dear students, we are having number 11. 11 is a two-digit number. We can write 11 as a, like in an expanded form, we can write 11 as a 10 into 1 plus 1. Okay. Suppose we are given another number which is 96. So 96 can be written as an expanded form as 10 into 9 plus 6. Okay, because this give 10 plus 1 which is 11, and here 90 plus 6 is 96. Suppose, dear students, I just wanted to write that xy is a two-digit number. So can I express this xy as a 10 into x plus y? Yes or no? Yes. If it is 3-digit number x, y, z, so I can write it as in the expanded form as 100 into x plus 10 into y plus z. Here what is happening over here is that we have multiplied the unit place with 1 and added the 10th place by multiplying it with 10. So x, y is a 2-digit number which can be written as 10x plus y. X, y, z are the 3-digit number which can be written as in the expanded form as a, since we multiply z into 1, y since it is in a 10th place, so it will be multiplied with 10, and since x is in the 100th place, so we have multiplied with 100, and we have this writing the 2-digit number, 3-digit number or n-digit number in an expanded form you should learn. And based on this, I have one question to you. Just see on your screen. You can see one question visible to you in your screen. This is the last question of this video. A 2-digit number is 4 times the sum of the digit. It is also equals to 3 times the product of the digits. Find the number. Okay. Read the question again and again and try to solve by your own. Pause the video and try to solve the question by your own. Let me repeat the question for you. It says that a 2-digit number is 4 times the sum of the digit and it is also equals to 3 times the product of the digit. Find the number. Okay. Find the number. Pause the video and try to solve by your own. Okay, just look into the whiteboard. Dear students, the question is that let x be 10 place digit and y be 1 place digit. Okay, 1 place digit. So the required 2-digit number be, so 2-digit number be x, y, which is 10 times x plus y. I have written this 2-digit number in a expanded form. Okay, now see, according to the question says that a 2-digit number is 4 times the sum of the digit, that is x plus y, which is 10x plus y is 4 times the sum of the digit, that is x plus y. This is the first condition. And second condition says that this 2-digit number, that is 10x plus y, is 3 times the product of the digit, that is 3 times x into y. This is the question, dear students. So just try to solve the things. Like, can we say that from equation number, if you take this as equation number 1 and this as equation number 2, from 1 we can have 10x plus y is equals to 4x plus 4y. Expanding this, we can write this. This will give 10x minus 4x, 4y minus y, which is 3y, and here it is 6x, which is equals to 3y. Okay, so 6x is equals to 3y. Okay, this will give 2x is equals to y. Yes or no? Yes. Let us take this as a equation number third. Now put equation number third in a second. Putting third in a second. What we will get, dear students? We will get 10x plus y is equals to 3 into x, which is 10x plus y is equals to 3x into y. Putting the value of y as equals to, this is equation number second. So putting the value of y, which is 2x, I will get 10x plus 2x is equals to 3 into x into 2x. Okay, this will give 10x plus 2x is 12x, 3 into 2 is 6, and this is x square. Okay, 6 it will cut for 2 times. Yes or no? Yes. And this will remain as a, this will be 2x x square. Here the value of x will be 2 because one power will get cancelled with this, so the value of x is 2. Now this is equation number 4. Put equation 4 in a third, you will get the value of y. So if I put the value of x is equals to in a y, I will get the value of y is equals to 2 into 2, which is just 4. Okay, so we have got the value of x is equals to and the value of y is equals to 4. So most probably this required 2-digit number B. The value of x is 2, the value of y is 4. It is 24. Okay, so the required number is, so the required 2-digit number is 24. This is the word statement which has been solved by using quadratic equation. I hope this video lecture was helpful for you. Thank you everyone for watching. I hope you like this video. Keep practicing more questions from the NCERT book. Thank you everyone. Happy learning.